Okay, let's jump right into this explainer. Imagine a massive manufacturing plant, right? Worth, say, 500 crores. Suddenly, it just grinds to a complete halt. And it's not because of a labor strike, or a power outage, or even a supply chain failure. It's simply because local authorities cut off its water supply. In India, this isn't some hypothetical drill anymore. It is an active, critical, operational risk. Now, while most companies look at Zero Liquid Discharge, or ZLD regulations, as this horribly expensive compliance burden forced on them by pollution boards, India's smartest manufacturing companies, well, they're actually flipping the script. They're turning this environmental mandate into a massive operational advantage and a very real return on investment. Let's see how.
We've got a really packed agenda today, and this is basically going to function as a strategic corporate briefing for you. We'll quickly run through India's industrial water crisis, break down exactly what zero liquid discharge is, do the math on how it actually generates ROI, look at a smart blueprint for implementation, and finally, discuss how securing your corporate water changes everything.
So, Part 1, India's industrial water crisis. We really need to set the stage and understand the harsh reality of the environment we're operating in right now. Because seriously, what actually shuts down a massive, sprawling plant faster than a power outage? It's the sudden, unexpected loss of water. If your plant relies heavily on outside water tankers or local bore wells, your entire production line is basically sitting on a highly fragile foundation. It's a ticking clock. To ground this in hard data, look at India's industrial water reality. India holds roughly 18% of the world's population, but we only have about 4% of its freshwater resources. And right now, nearly 70% of our surface water is considered entirely unfit for consumption. Because of this massive imbalance, groundwater tables across major manufacturing hubs, places like Tamil Nadu, Gujarat, the NCR, and Maharashtra, are just depleting at an absolutely alarming rate. And this vulnerability is off the charts for water-intensive sectors, like textiles, for example. They require millions of liters of water just for dyeing and processing. If they fail to secure a reliable internal water loop, literally just a single seasonal drought or a sudden municipal water cut can completely stall millions of dollars in production.
And because of this severe scarcity, we're seeing a massive regulatory squeeze. State pollution control boards are fiercely cracking down on industrial extraction and effluent dumping. We are officially in the era of extended user responsibility. What that means is, if you operate in a designated red zone, which is an overexploited groundwater area, securing your wastewater management, it's no longer optional. It is a strict prerequisite for your consolidated consent and authorization. Without it, you are looking at immediate closure notices. Game over.
Okay, moving to Part 2. What is zero liquid discharge? Let's totally demystify the actual engineering behind the solution to this whole crisis.
So, the absolutely crucial point here is that ZLD is a closed-loop engineering process. Instead of treating water just enough to legally dump it into a local river, ZLD fully purifies and recycles all the wastewater generated inside your facility. It's like a giant puzzle that perfectly fits together to infinitely cycle the very same water through your factory, leaving literally zero liquid discharge at the end of the line.
And the process flow itself is actually quite an elegant, simple three-phase stack. First up, you have your pretreatment. This removes suspended solids and uses biology or chemicals to soften up the water. Second, you push that pretreated water through advanced membrane filtration, like high-recovery reverse osmosis, separating out the beautifully clean water. And finally, that concentrated, sludgy reject water that's left over goes through thermal evaporation and crystallization. You're literally just boiling off the rest to leave safe, dry, solid salts that you can safely dispose of or even reuse.
The sheer efficiency of this is staggering. Top-tier ZLD plants recover anywhere from 95 to 98% of their water. Really think about that for a second. You are virtually eliminating your dependence on outside municipal lines or commercial tankers. You've essentially created your own infinite internal water source.
Which brings us right to Part 3, the math. ZLD as ROI. This is the core financial pivot the corporate viewers really need to pay attention to. How do we turn this massive capital expenditure into a genuine return on investment?
Well, as you can see, the highest polluting and most water-reliant sectors are already pivoting aggressively towards ZLD. The chemical industry makes up the massive 40% of implementations, followed closely by textiles at 25%. And listen, these industries aren't just doing this out of the goodness of their hearts to be green. They're doing it to protect their operational continuity and save their bottom line.
When you sit down to calculate the ROI, you have to look way beyond the initial equipment costs.
This formula here shows the true net operational return. You've got to factor in the huge long-term savings from not having to buy fresh water, the commercial value of those recovered chemical byproducts, like salts that you can reuse in dyeing processes or even sell, and of course, the massive financial value of regulatory insurance. Guaranteeing 100% operational uptime, even during severe summer droughts, means a well-engineered ZLD plant frequently pays for its entire capital expenditure within just 3 to 5 years. It's incredible.
Let's do a side-by-side comparison. The old way is just full of escalating, totally unpredictable costs, right? Buying expensive commercial tankers, getting hit with rising municipal tariffs, and risking massive business-ending pollution fines. The new ZLD way, though, it gives you predictable, fixed operating costs, usually around 80 to 150 rupees per kiloliter. Plus, you get those potential revenues from saleable recovered byproducts and, most importantly, 100% regulatory peace of mind.
Furthermore, the underlying technology is just getting cheaper and cheaper to run. Modern innovations in thermal evaporation, things like mechanical vapor recompression, are slashing the energy costs of that final boiling stage by almost half. So Part 4, Blueprint for Smart Implementation. How do top plants actually deploy this stuff without falling into common, super expensive engineering traps? Let's look at a highly practical blueprint.
All right, here is your practical 3-step playbook if you're a plant manager. Step 1. You absolutely must conduct a comprehensive water audit before buying a single piece of equipment. Map out every single point of consumption in the facility and segregate your streams. Keep the easily treatable water far away from the highly toxic stuff. Step 2. Prioritize reverse osmosis recovery over thermal. Thermal boiling takes a ton of energy, so maximize the efficiency of your membranes first to minimize the volume of water you actually have to boil. And Step 3. Integrate smart, digital IoT sensors to monitor everything in real time.
That IoT monitoring is absolutely critical because of a nightmare scenario engineers call the scaling trap. Missing even a tiny 1 millimeter layer of scale buildup on your heat transfer surfaces will instantly reduce your thermal efficiency by 40%. That will drive your energy costs through the roof overnight. Smart digital sensors track that water quality and flow rate, catching scale buildup and system leaks way before they cause a wildly expensive plant breakdown.
And guys, these aren't just theoretical numbers. From major steel giants like Tata saving over 4 crores annually, to textile plants like Grasim securing massive 98% recovery rates and saving over $100,000 a year, the wins are real. Even automobile manufacturers like Toyota Kirloskar secured their core operational licenses in highly water-stressed corridors simply by integrating advanced water reuse. Smart ZLD engineering translates directly into a bulletproof balance sheet.
Finally, Part 5, Securing Your Corporate Water. Let's wrap this up by zooming out and looking at the big picture for your facility's future and how this directly ties into global finance. We absolutely have to shift our thinking from the old paradigm to the new one. Water is no longer just some cheap utility you can take for granted. It is a highly strategic asset. Securing your corporate water loop makes your balance sheet look incredibly attractive to institutional lenders. Strong water circularity scores open the door to foreign ESG funds that offer lower interest rates and green financing. It's not just a nice-to-have, it's a massive valuation boost.
Securing your corporate water loop isn't just about protecting the environment anymore. It's about protecting your bottom line. So I'm going to leave you with this final thought. If the municipal taps ran completely dry tomorrow, how long would your factory actually survive? What steps has your manufacturing unit taken to tackle water scarcity and secure its operational baseline? Let me know in the comments down below. Make sure to subscribe, hit that bell icon, and please share this explainer with operational directors and factory heads across India. Thanks so much for joining me today.